Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
Welcome to this explainer. Tell me if this sounds familiar. Have you ever felt like a piece of technology was just actively fighting against you? Like it literally had a mind of its own? Well, today we're going to explore exactly why that happens through Donald Norman's 7-stage model of interaction. We're going to decode something that happens to you dozens, maybe even hundreds of times a day without you even realizing it. Okay, let's dive into this. It's a completely universal problem, right? You sit down at a brand new software dashboard, or maybe you try to set up a new smart home device, and it just feels ridiculously frustrating. Why is that? Why do some systems feel completely intuitive, like an extension of your own mind, while others feel like a massive puzzle you have to solve just to get a basic task done? Well, Donald Norman argues that to figure out where these systems fail, we first have to break down exactly what happens when a human being tries to do literally anything. To really ground this abstract theory, Norman uses this wonderfully simple, hyper-relatable scenario. Just imagine you're sitting in a really comfortable chair, getting lost in a great book as the evening falls. Slowly, the room starts getting darker. Eventually, you hit a point where you realize, hey, I need more light to keep reading comfortably. This incredibly simple, everyday occurrence is actually the perfect starting point to map out the lightning-fast micro-interactions happening between our brains and our environment. To solve that dark room problem, you actually go through a highly specific sequence. Norman maps it out into 7 distinct stages. Ready? 1. You establish a goal. 2. You formulate an intention. 3. You specify your actions. 4. You execute the action. 5. You perceive the state. 6. You interpret the state. And finally, 7. You evaluate the state. And what's key to remember here is that Norman's entire model concentrates strictly on the user's view of the interface. So the crucial point is how this cycle is split into 2 halves. This first half is the execution phase. It starts with a pretty vague, imprecise goal. I need more light. But from there, it moves incredibly fast. That goal translates into a specific intention. I'm going to switch on the desk lamp. Next, you specify the actual physical actions. You decide to reach your arm over. And finally, you execute the action by physically pressing down on the switch. Just like that, you've moved from a hazy thought to physical execution in 4 seamless steps.
But here's where it gets interesting. Notice how flexible this is. Your primary goal is still exactly the same. I need more light. However, your physical environment dynamically dictates your intentions and actions. Say someone else is sitting way closer to the lamp than you are. Suddenly, your intention shifts. Instead of reaching over yourself, your intention becomes asking them to do it. So your action is now opening your mouth and speaking, rather than reaching out your hand. The goal remained totally identical, but your execution path completely changed.
Let's move to and see how this builds into the second half of the loop, the evaluation phase. So you've executed your action. You flip the switch. Now your brain immediately has to process what happens next. First, you perceive the new state of the system, meaning your eyes physically register if the light changed. Then, you interpret that state based on your expectations. Finally, you evaluate whether this new physical reality actually satisfied the goal you started with back in step 1.
Now, let's introduce a little failure into our story. You reach over, you press that switch, and absolutely nothing. The light does not come on. You perceive the dark room. Now you have to interpret this state. And this relies heavily on your everyday knowledge of the world. You don't just give up right there, right? Your brain starts deducing. Did the bulb blow? Is the lamp unplugged? Is the power out entirely? You're interpreting the system state to formulate completely new goals to fix this new problem.
But what if the light does come on? Well, you perceive the brightness, you interpret that the lamp is working, and you evaluate this brand new state against that original goal. You naturally ask yourself, is there now enough light to read? If the answer is yes, boom, the interaction has been completely successful. The 7-stage cycle is done. But let's say the desk lamp is way too dim. You'd formulate a brand new intention, like getting up to turn on the main ceiling light, and the whole cycle begins all over again.
Now, what's really interesting about this slide is Section 1, Mind the Gulfs, when interfaces fail.
To figure out why interfaces cause so many headaches, we apply this everyday logic straight to technology. Norman uses this exact 7-stage cycle to show us the breakdown points, what he brilliantly calls gulfs. But to understand these gulfs, we first have to recognize that you and your computer are basically speaking 2 completely different languages. We have the task language, which is how you, the user, think about your goals. You're thinking, I want to edit this photo, or I want to send a message. Then we have the core language. That's the language of the system itself, how the software actually processes data. Friction happens simply because you and the system are not using the same terms.
This language barrier creates our first major trap, the gulf of execution. Simply put, this is the gap between how you formulate your actions to reach your goal and the actions the system actually allows you to take. Every genuinely great interface out there aims to shrink this gulf as much as humanly possible. If the actions the system allows match up perfectly with what you intended to do, it feels like magic. It's smooth. If they don't, you hit a brick wall.
Think of it like a massive mismatch. On one side, you've got your incredibly intuitive goal and exactly how you expect to pull it off. But on the other side, you're faced with the software's rigid, overly complex controls and drop-down menus. When those two things don't align, you fall right into the gulf of execution. You know exactly what you want the machine to do, but you literally cannot figure out the exact sequence of clicks it requires to make it happen. It's maddening.
But, what happens after you finally manage to click the right buttons? That brings us to the second trap, the gulf of evaluation. This is the distance between what the system physically shows you and what you actually expected to happen. Once you take an action, the computer does something. But if you have to burn a ton of mental energy just to interpret what it did, or if you can't even tell if your click actually worked, the whole interaction completely falls apart.
And this brilliantly illustrates the second mismatch in our model. You just took an action, and you have a very clear picture in your head of what the screen should look like now. But the actual presentation of the system state, it might be totally different. Maybe a tiny, invisible loading wheel appeared somewhere in the corner, or some cryptic error code popped up out of absolutely nowhere. The system's physical feedback completely failed to match what you expected to see. It leaves you confused, stranded, and totally unable to finish that 7-stage cycle.
So, let's bring all of this together. Norman's model isn't just some abstract academic theory. It's actually a super practical diagnostic tool for your everyday life. Next time you find yourself wanting to throw your phone across the room because of a bad app or a frustrating self-checkout kiosk, I want you to pause for a second. Ask yourself, are you stuck in the gulf of execution, completely unable to figure out how to tell the system what you want? Or are you trapped in the gulf of evaluation, unable to decode what the system just did? Recognizing which gulf you're stuck in is absolutely the first step to mastering your technology, instead of letting it master you. Until our next explainer, keep questioning the systems around you.